Our experiment is focusing on the bipolar technology from the kinematic perspective in the light of the functional parameters. As we know, bipolar technique has always been one of the most debated phenomena in archaeology. Bipolar technique is a kind of flaking and retouching strategy. Absence of specific geological and chronological distribution is its one of the main characteristics. In the last 2 decades, so many studies have been published in terms of archaeology, ethnography, especially experimental studies, from the technological and functional perspective. Bipolar technique has always been associated with negative connotations in terms of its simple mechanic, such as reduction of small-size elements, also the low skill of hominins in the flaking activity. Indeed, this hypothesis is the reason why we wanted to conduct an experiment. Around the late 70s, Patterson and Solberger published their famous paper on bipolar technology, which mentions about this idea. The following year, their idea was refuted by several researchers, such as John Peter White, Gary Hines. Starting from this point, we have prepared our research question. Is there any quantitative and qualitative differences between the nappers with different levels of expertise when flaking using the bipolar technique? Our archaeological reference point of the experiment on bipolar technology is the Middle Pleistocene site of La Cancereta in northeastern Spain. In terms of the industry, the site is very rich. Also, presence of almost complete reduction sets play an important role to identification of the flaking strategy. So, after the experiment, we made comparisons with the archaeological and experimental samples. We have collected 12 quartzite pebbles from Francolí River. As you can see, we have respected the dimension of archaeological refit sets strictly. Also, we collected 1 quartzite hammerstone, 1 granite anvil. 3 main levels of expertise were identified, and each group includes 2 female and 2 male participants. Totally, we worked with 12 volunteer nappers. Video motion analysis is used with several disciplines in sport, engineering, etc. The importance of this experiment is the first video motion analysis for the bipolar technique. Of course, we have prepared our experiment area in a well-organized way. In the video motion analysis, the most important case, the calibration of the video and the position of the camera. The camera must see the moving object in a horizontal way. We worked with 2 cameras. The first camera was for the raw video recording of the analysis. The second camera is for the slow motion recording to see the gestures of the nappers in a better way. We used the tracker software for the analysis of the videos. Each participant had 2 minutes to flake the pebbles. The aim of time constraint is to evaluate all participants in an equal duration. Each participant used green neutral gloves against a black background, because the color contrast plays an important role in the tracking of the moving object. The testing of motion mechanics of the bipolar technique was based on 4 functional parameters. These parameters represent the quantitative values of the position, velocity, acceleration, and kinetic energy of the moving object. Y-position component displays the position of the moving object relative to the y-axis over time. In bipolar reduction, the moving object is the hammerstone. The point where the hammerstone meets the core is defined as the 0 point. The hammerstone moves away from the 0 point or the core with the upward movement of the hand of the napper. It moves closer to the core or the 0 point when the impact is attempt to obtain a flake from the core. Velocity magnitude displays the velocity of the moving object over time. Velocity is the rate of the displacement of an object. The velocity of the hammerstone depends on the force applied by napper and the mass of the hammerstone. The peak point on the graph shows the moment when the velocity is the highest. This point is just before the hammerstone meets the core. Acceleration displays the acceleration of the moving object relative to the y-axis over time. Acceleration shows the change in the velocity of the moving object over time. When the velocity of an object decreases due to a force, it is defined as negative acceleration. And when the velocity increases, it is defined as a positive acceleration. In the graph, the negative acceleration was recorded during the upward movement of the hammerstone. This is because at this time, the hammerstone was ready to contact the core. Therefore, it is even when the moving object is at its slowest moment. The positive acceleration was recorded just before the hammerstone meets the core. This is when the moving object is at its fastest moment. Kinetic energy displays the energy of the moving object over time. It also shows how much force is applied by the napper during the flaking process. The peak point on the graph shows the point where the kinetic energy is the highest. This point is reached just before the contact the hammerstone with the core. In addition, the lowest point recorded immediately after the highest point indicates the contact of the hammerstone with the core. At this point, the kinetic energy of the hammerstone is almost zero due to the contact of moving object with a stationary one. Statistical analyses were applied to understand whether there were any differences in functional parameters between participants, levels of expertise, and gender groups. All the statistical analyses were performed in IBM SPSS version 29. Our statistical analysis aimed to test our null hypothesis. There is no significant difference between the levels of expertise and gender regarding functional parameters. The results of the experiment were quite interesting. When we have a look at the slow motion records, novice snappers show no control in hammerstone and orientation of the core. Almost zero detachment was observed. They just bash the pebbles in an uncontrolled way. Intermediate nappers presents better condition relative to the novice napper. However, they still cannot control the core and hammerstone. But the expert nappers has full control of the hammerstone and core. The aim of the expert nappers is optimal use of the raw material. As we can see, the differences in reduction strategy can be seen very well across the levels of expertise. We can see zero detachment in the case of novices. Intermediate nappers present short reduction sequence. However, experts flaked all the raw material units completely. Statistically, position of hammerstone, velocity, and kinetic energy presents significant difference between the participants. In levels of expertise, velocity and kinetic energy show the differences. Between gender groups, position of hammerstone, velocity, and kinetic energy shows the differences. In terms of levels of expertise, significant differences were detected on the velocity and the kinetic energy parameters. The graph shows intermediate nappers apply more velocity and kinetic energy than the others, because the intermediate nappers is focusing on the splitting the pebble with the maximum velocity and maximum kinetic energy. However, expert nappers apply maximum kinetic energy only once just to split the pebble. After this, they keep the velocity and energy at constant level. This shows how experts use the hammerstone in a more skillful way than the others. Technological categories do not show differences. Individual material analysis is not suitable to see the levels of expertise on the material, but refit analysis is playing a very important role in this case. As we can see, expert nappers present more complex and long reduction strategies than the others. In terms of gender groups, height of the hammerstone, velocity, and kinetic energy has the highest value. Unfortunately, these are not the indicators between female and male nappers. Our sample size regarding gender is not enough to make an inference. But if we can focus only on gender and bipolar concept with larger samples, we could have more chance to interpret this issue. Women and bipolar technique have been reported by several researchers in the literature. However, it's not important who applied this technique. What important is why it was applied. In which sense? The studies of Sylvia Albright clearly show Tahltan women in British Columbia apply bipolar technique more than expedient tool concept for the hide working activity. This is not a being a female and male, because if we have focused on the Papua New Guinea, more complex variants were applied by the Duna men in the highlands of this area. La Cansaladeta was our starting point to investigate the bipolar technique. We can clearly say small-sized fluvial materials were flaked by bipolar on the anvil technique in La Cansaladeta. It is not surprising to see the bipolar pattern in MIS-11, if we think about its wide distribution regarding time and space. As a summary of our study, we can reject our null hypothesis This means bipolar technique requires a skill and shows differences in the functional parameters. So far, we can only rely on refit analysis to identify the levels of the expertise. We must stress our study is not a conclusion on bipolar technology. On the contrary, it stresses its complexity and shows more detailed comparative analysis need to be done. Also, confusion in the bipolar world continues, not like 20 years ago, such as differences between the splinter pieces and bipolar cores. Currently, this discussion shows a tendency to identification of the different variants of the bipolar technique, like in the ethnography and ethnoarchaeology. Finally, we just want to conclude our presentation with the words of the master. Bipolar technique has a simple mechanic. However, its aim, application, and interpretation is very far away from the simplistic approach. Thank you so much for your attention.